done here? See, I am once again showing you the syllabus. Clearly, it is mentioned chopper classifications. What we have covered in the previous class. Basic chopper operation. We have to discuss basic chopper operation. That is today's topic. I am going to discuss that one. What is basic chopper operation? How exactly? In that one, step down and step up and step and down, up and down. 3 different types of choppers we are going to discuss. Only these topics are there in your syllabus, not beyond that one. Okay, that is chapter number 8, 8.1 to 8.33. Moving ahead, this I already taught you. This is where I supposed to go for it. In general, whenever you go for the chopper, as we know that, as we already know that one, input is DC. My input voltage, what I am having is pure DC only. My output also I need to convert that to DC. So your input signal what you are going to have a voltage is a DC voltage that needs to be converted into variable DC voltage. How to convert that one? We have some load. To that load we have to apply the DC voltage. Take an example. I am having a laptop. I am having a display. Display equals 8 volts. My input is 12 volts. My display equals 8 volts. So I need to step down that one to 12 volts to 8 volts. How to do this? We have to do this using some small switch. Which device is like as a switch? Generally we will say that one diode is a switch. But for the stepping down operation, we cannot go for the diode, we have to go for a transistor. A transistor can be used over there. So I will be using this transistor as a switch. In our chopper operation. Which type of transistor? There are varieties of transistors are available. We are going to have a UJT, we are going to have a BJT, we are going to have IGBT, we are going to have MOSFET, we are going to have SIT. Varieties of transistors are available, but in general, I am not going to use unijunction transistor. I will be using bipolar junction transistor. I may be using insulated gate control transistor. IGBT we call that one. Insulated gate bipolar junction transistor. This is bipolar junction transistor. Photograph this. I can use. I will not use UJT. I will be using bipolar junction transistor, or I will be using insulated gate. Insulated gate, bipolar junction transistor. What is MOSFET? MOSFET. Have not come across MOSFET? Metal oxide semiconductor field effect transistor. Metal oxide semiconductor field effect transistor. Metal oxide semiconductor field effect transistor, and the last one is static inductive, sorry, not inductive. Yeah, static induction transistor. It is unijunction actually, where step up and step down is not possible. It's only one junction we are going to have. You take it. Only one junction. Then what's going to happen? In general, we're going to have a collector emitter base. Okay. And still you can be terminals. But bipolar junction transistor, where you can step up or step down. Either you can increase because it is like forget this one. There is one more way of converting the signal choppers, like AC link. You can use the AC link. Means DC to AC, AC to DC can convert. That is previous topic. The further we explain. DC they convert into AC first they using the inverter. Then once again the AC system they want to convert to DC. What happens? Using when you are converting AC, DC to AC, AC to DC, there is a more tedious process, more complicated process. Similarly, when you go for the UJT, you are not in a position to go along with the parameters. There may be a fluctuation, there may be a noise, because so many equations I have to solve those things. To go for UJT, lot of expressions I need to solve. So that is complicated when you go for the PJ. Or otherwise, you can say that multiple UJTs is supposed to integrate and you should go for. So instead of that one, I can go for bipolar junction transistor. Okay. So these are the four different types of transistors. Generally, they are going to use for chopping operation, for converting DC to DC operation. UJT is limited, where noise will be there, and it's not suitable for converting DC to DC choppers. Okay. These are the four different types of transistors where I can use for chopping operation. Here is the example they have given, a diagram. Simple circuit it is, very simple circuit. We don't feel complicated. I can rewrite the circuit like this. I'm having a VDC. VDC is there. I will be connecting a switch. A switch will be connected. With that one, I will be adding a load. The circuit is same as this. The circuit is same as this, but he has given one diode. Correct? A diode has been given. See here, I'm having a load on the right side. In parallel with the load, I'm having a diode. In between, I have given the inductive. At present, you forget this. Just forget the induction. Okay, let me make it simple. The circuit, what it is given in the display projection, it is same as like this. There it is clearly given it is a transistor we are using as a switch. Here I have mentioned just a switch. It's a switch. Last performance. Super ತೊಂದರೆ ನಿಮ್ಮಿಂದ ತುಂಬಾ ತೊಂದರೆ. Kindly be silent so that I can concentrate on the topic. My flow will get affected. So here, coming back to the topic, the circuit what is given, though it looks very big, in a different manner they have given. Instead of horizontal, there is a vertical manner they have given. Horizontal, I give the switch. I told which is the switch we are going to use. We are going to use any one of this one. We are going to use this one. So assume I am using a BJT. So here I should replace this switch with the transistor what I am having. A transistor is kept. A transistor Q1. They have kept in a tilted manner. 90 degrees they have tilted about it. So I don't want to make it that much complicated. I am writing it like this. Where a switch we can use. What happens? What is the process? How exactly? We are having VDC as the input. Input is VDC. Okay. So I will be having a DC. switch is on, whenever the switch is closed, whenever the transistor is conducting, when the switch is closed and the transistor conducting, whatever the DC power supply we are adding over here, whatever the DC that flows to the load, right? That flows to the load itself. It closes and comes along this one. Since it is a reverse bias, it is closed, it is open. Diode is reverse bias. Okay. Here I am going to have positive. The positive signal is coming. Diode is reverse bias. Diode is going to be open circuit. So whatever the input you are transmitting, the same input will come on the load also. That is output V naught. Correct? Any confusion here? When the switch is closed, that is when the transistor is forward biased. When the transistor what we are using is forward biased, it is closed, and whatever the input signal we are transmitting, whatever the voltage we are having, the same voltage will appear on the load also. So my V naught, output voltage, which is almost your VDC. What is the input voltage we are having? I am going for. Assume I switched on at the 0. My time interval is 0. At 0 time, I switched on my switch. The switch is closed. The transistor is working up to some time interval. Up to some time interval, the switch is closed. After that, the switch is open. I intentionally open the switch. Okay. You just compare with the real-time examples. Like initially, I have closed my window pane. Initially, I closed my window pane of my vehicle. Okay. So I felt it is very hot inside the car. I am driving. I felt it's very hot. What I will do? I want to open that. I want to open it. So I can window pane can be dropped down. So you need to apply the voltage over there. Window pane can be dropped. It can be closed, it can be open. Any operation, both operations you can do that. If it is closed, it should be closed, it should be switch on. If it is open, it should be switch off. Both the operation you have to do that person. So after some time, I will be switching off my device. Switch is open, then your output voltage will be 0. It will drop. This is theoretically I am speaking. Theoretically, practically what happens now? It may go like this. It may take some extra time to come to the zero level. So let us not discuss about what is going to happen practically. We should go for theoretical value. This is some time P1 or P0. I will go for this is P on. P on time. P on time I am given note. Next is up to some time I will go for T off. When the switch is open, obviously it is T off. So I will go for T off here. It may be any time. It may be any interval. Switch is closed for 5 seconds, switch is open for 2 seconds. Or switch is open for 2 seconds, switch is closed for 5 seconds, depending on the requirement. Similarly, after this, I will open 1 second. So this is your T on, this is your T off, and this is T on. Whichever way you want, you can write it. See there? Gate current, that is because I am using the your transistor. I should know gate voltage. Some voltage I have to give triggering voltage. Transistor will either be switched on, so I should apply the triggering voltage. After applying the triggering voltage, it's going to close circuit, then it's going to operate, and I am going to get the voltage. The same. Whatever this is V0. Whatever the V supply you are going to have the supply voltage, the same supply voltage will come up to T1, then it's going to be T off. ಊಟ ಮಾಡಬೇಕಾದ್ರೆ ಟಾಯ್ಲೆಟ್ ಹೋಗಬಾರ್ದು ಅಡುಗೆ ಮಾಡ್ತಾರೆ just give the work to your ears applies to all our customers. Just assume, imagine what's going to happen. My output voltage, the second waveform what I am having here, is simply showing whatever voltage PS, that is supply voltage. In the diagram, it's given as supply voltage, I am going to say VDC. VDC is my power supply voltage, and in this one it's a PS level. So my output voltage is same as the supply voltage up to sometime T1. Up to T1 it is on. So I have one T on there. Okay, here is given as T1. Then up to T, it's off. Then once again it's going to be on, once again it's going to be off. It's going to be repeated. It's going to be repeated only. So here, what is happening here is my voltage is supplied to the load. You can raise a question. So where is it is dropping? Upper, it is going to step up or step down. Whether it is stepping down or stepping up. Whether it is stepping down or stepping up, you have to know that first. So theoretically, it's not showing anything. Since it's closed, whatever you are doing, it's coming back. Fine. When you want to know that, see here, V naught showing over there. Current also we can mention. Current also. I'll write the current waveform also. I naught initially it goes like this, then comes to 0. This is what your current across the load, current passing through the load, voltage V naught across the load, and current passing through the load, I can say it is I naught. This is V naught, this is I naught. It is passing through the load. Now, I want to know what is the output voltage, what I am getting over there. To know that, that is average load voltage. Because I need to measure the average. It is T on is there, T off is there, T on is there, T off is there. I want to measure the average load voltage. Average load voltage, that is V naught average, which is overall time is peak. Overall time, that is both put together, T on time and T off time put together, we call this overall time. So if I want to find the V naught average, whatever the voltage I am getting, that should be checked with the how much time you are taking for switched on and how much total time it is taking. That is V, again VDC, because as per my circuit explanation, I am giving VDC multiplied by VDC multiplied by the peak on time divided by total time. If you want to know the average voltage, that is output voltage in this particular circuit, which is using a transistor or which is in any switching device, I am having T on and T off, T on, T off. That is, I am getting some voltage when it is on, some voltage when it is off. It may be high, it may be 0. I don't know what it's going to be. So I need to know what is the average voltage I am getting across. So if you want to know average voltage across the load, you should give the input voltage, means what is the voltage you are getting, how much T on and T total. T total means T on plus T off. You can go for it. So if you want, I can write it VDC in T on plus T off. But when you look into electronics circuits, the on time divided by total time. Any doubts? Any clarifications? Discussion among yourself. Getting what I am. Okay. I am getting some voltage P on time. I am getting some voltage in P off time. But I want to know what is the total average voltage across I am getting across the load. That is average load voltage. We call this average load voltage or average output voltage, whichever you are going to call that one. So it's been given as VDC into T on by D to total time. Since T on by T total is called as duty cycle, which is equal to delta. Just replace T on by T total by delta. Replace T on by T total by delta. Therefore, V naught average is equal to VDC into delta. Now, we'll come to the topic. Step down. We are supposed to come to a conclusion whether it's a step down or step up. He's doing some operation. I told you chopper, either it's going for step up or step down. Two types are there. We have to verify whether it's a step down or step up. How to verify? Take some example. Assume VDC is 10 volts. Some 10 volts are added. VDC, the input voltage is 10 volts. Okay. T on is 5 seconds. T off is 5 seconds. What's going to happen? Put it in the equation, check it out. Put it in the equation. V naught average is equal to 10 volts into 5 divided by. How much you get? You will get 10 only? Sure? How much you got it? My input voltage is 10 volts. T on time is equal to T off time. T on time is equal to T off time. Both are same. How much time I am switching on? The same time I am switching off. 50%. So obviously your output voltage will be 50%. If your T on time is more and T off time is less, T on time is more and T off time is less, obviously your average voltage is going to be a bit more only. Okay? Assume that I have 8 seconds and 2 seconds. 8 seconds is T on time and 2 seconds is T off time. 8 divided by 10. You are going to get 0.8. 0.8 into 10. So the 8 volts you are going to get. So input voltage is 10 volts. My output voltage, what I am getting, average output voltage, what I am getting is 8 volts. It is stepping down. It is stepping down. Similarly, we can go for step up also. Okay, we will see that how exactly step up is going to work. Understood how exactly step down is going to work. Whichever the transistor you use MOSFET or BJT or IGBT or SID, anything, you can go for it, you can check it out. Depending on the T on time and T off time, we are able to measure whether it's a step down or step up. Okay, step up is here, we should have a different circuit code. I have written the circuit here with load. What is the purpose of that? Already we have discussed. Inductor. If there is an inductor, assume that the inductive role is there and we don't have the diode. Inductor is getting charged and there is a radio sector where it is going to discharge. The discharge voltage will be applied across the output and you are going to get negative voltage also. To overcome the negative voltage, we are going to use the diode as a freewheeling diode. Because it's freewheeling diode where it's going to free out all the extra voltage, negative voltage what they are getting. That will be nullified voltage. So This diode what we are using in the circuit, DM they have mentioned, I have written as D or I have not written anything. Okay, DF, freewheeling diode we are going to call that one. This freewheeling diode will eliminate the or will nullify the extra voltage which is generated by the your load. What are the load? Or inductor or capacitor, whichever the device you are going to have that, no? It will be discharging. The discharging can be nullified. Because, assume simple example, let me take my laptop once again or mobile itself. Assume there is a reverse current. Should not have a reverse current, should not have a reverse voltage. Voltage should not reverse to damage your equipment. Other equipment is running, so damage that. So, anyway, if you run a reverse voltage and reverse current, that needs to be nullified. So, we are going to have a freewheeling diode. The simple example is you are charging your mobile, it's fully charged. Fully charged. In the general instruction, generally they will say, if it is less than 20%, immediately you have to keep it for charge. If it is more than 8%, you switch off the charge. That is what general instruction. Because they themselves cannot assure that it is 100%. 100% calibration, they cannot assure. Nobody can assure that it is 100% calibrated. Very, well, I guess 0.0001% of equipment can be calibrated for 100%. Wherever sophisticated airbags, military equipment, where we need to have instant outcomes, 100% efficiency principle, they are can be all general equipment what they do in household equipment, other kind of equipment, they cannot have 100% efficiency. 100% efficiency they cannot ensure. For example, is I will say the print load washing machine or top load washing machine. So it will say if you put exactly 6 kgs of cloth, it will take 1 hour to wash. Only they can say. Practically, they cannot ensure that it's 1 hour exactly to take. Okay, you could have measured the cloth exactly 6 kilo. You measure it. You put them into the washing machine. Switch on your washing machine. Everything is perfect. Inlet is perfect. Outlet is perfect. So power is okay. But it will not. It should be exactly 1 hour. It will take. What are the values? They cannot assure. So there may be some variation. Similarly, here also, a mandate. Why I need to have diode as a freewheeling diode is any negative current and negative voltage is there that needs to be understood. Okay, so understood. See here V naught experience delta Vs. They are given Vs. Vs is source voltage what they are given as supply voltage in this circuit, but I am given as VDC. Which are the terminal you can go for that. Don't have a confusion. Vs is same as VDC and V naught is same as V naught average. Okay, I have found out the average. I need to find out the RMS voltage. Okay, that is the equation. RMS output voltage can be root of VDC square into P on divided by P total. ಅರ್ಥ ಆಯ್ತಾ? Got it? Transfer ಆಗ್ಬೇಕಾದ್ರೆ So, SCR input is there, anode is there, cathode is there. Anode is supply voltage voltage. Cathode is connected to your load. But gate is not connected to your supply voltage. Gate is separated into voltage voltage. Gate input voltage should give. Here also transistor of load should give the VGE. Separate VGE. Load will connect to VDC to VGE. VDC is different, VGE is different. VGE is a small voltage that going to supply to the transistor to just switch on. Just switch on the switch on ಆಗಬೇಕು ಎಲ್ಲ ನಮ್ಮ ಕೊಟ್ಟಿದ್ದಾರೆ ನಾನು ಕೊಡ್ತಾ ಇದ್ದೀನಿ ನಮ್ಮ ನಾವು ಸ್ವಲ್ಪ ಕ್ಲಿಯರ್ಲಿ ಕೊಡ್ತಾ ಇದ್ದಾರೆ ನಾವು ಆವಾಗ ಚಾರ್ಜ್ ಆಗುತ್ತೆ Just I'll run through the slides. Any doubts? See here, they have used the thyristor, a chopper. When the switch is closed, T-on. See, they have told they can use MOSFET, they can use GTO, force commutated. Okay, it's coming. VDC, IDC, T-on, T-on, T-on is equal to T is equal to T-on and T-on. F is equal to 1 over T. So VDC is equal to V into T-on by T-off. The same thing what I have written. VDC is equal to V into T-on by T. Delta, it is delta. Actually, they have not given delta, they have given D. So similarly, average output current, ID is equal to VDC by R. You can note down that also. IDC is equal to current, what I have written here, this is the current, I naught, which is given as similarly VDC by R. Whatever the load we are going to have, if I am having 5 volts my output, if the resistance is 100 ohm, 5 divided by 100, I am going to get some current over there. Okay, RMS value, which has been given. IDC is equal to V by R into T-on naught by T, T-on by T, where T-on by T is a delta. That is what? Delta is, what is delta? Duty cycle. Duty cycle. The word duty cycle you should know. Duty cycle in the sense how much time it is taking to on with respect to your total time. That is duty cycle. The fraction of on time divided by total time is a duty cycle. IDC, then VRMS. If you note down the IDC, I'll move to the next slide. RMS, C delta, root delta. I given root delta here. VDC too. Similarly, power. You should know about the power. Power is simple. I naught into V naught. Don't get confused. V naught. It is VDC. You can write it out. Or V naught average. V naught average it is. It is average voltage, average current. I'm getting I naught is equal to V naught R, P is equal to V square by R. All are same only. Okay, na? Any doubts? ಮುಂಗಡೆ ಕೂತ್ಕೊಂಡು ಡೌಟ್ಸ್ ಕೇಳಬೇಕು. ಮುಂಗಡೆ ಕೂತ್ಕೊಂಡ್ರೆ ಡೌಟ್ಸ್ ಕೇಳಬೇಕು. Done? Okay.
I'll stop it now.